leave that till tomorrow, because I got a really nice message from Chuck McLeester back in June. I thought it was more recently than this, but back in June, Chuck did an article in Target Marketing about how many marketers are not covering the statistical significance in their testing, that they're not testing enough and they're not getting enough results. And it's a very, very solid point. And I commend Chuck for saying it, because too often right now we're not even testing. I mean, we're not testing at all. We're running a banner ad and measuring the number of click-throughs, and we're saying, okay, that's enough, and running it for, an hour. And we get 50 of one and we get 70 of another. And Chuck points out rightly that even though he has his detailed explanation of how incremental differences between small sample sizes and small results can be taken as meaningful when they're really not. And Chuck is absolutely on point and absolutely right about that. And so I want to, and I think I had that in there, but with me, sometimes these are unrehearsed, these are live, and believe it or not, these are live, and I wing it, and I try to start at 10 on the dot, which today didn't happen. But so I don't always say what I expect to say. Let's just say. Anyway, so Chuck wrote me a private note because he felt like I had had publicly shamed him smugly, which I may have. So I may agree with him on that point also. It won't be the first time that I've gone a little over the top. And Chuck pointed out, and I don't know if I should, since it's a private message, I tried to explain in my statistical, let's just say I don't have a PhD in statistics, let's say. But Chuck wrote me and said, that doesn't matter, you don't understand, I got all my data from a chart. And Chuck lectures at Rutgers, and he's really got great qualifications, which I have very few. I only did Marquette and Carroll University and University of Illinois, or Illinois State rather, and a couple of those. Kansas University. Oh, here, yeah. UMKC. I was the top rated in Bob Stone's class, but it wasn't about statistics. So anyway, Chuck sent me this nifty chart, which I appreciate. This good chart, and it's from, let's see what he said. He said, and I won't show the whole message, but he said that it was from, he circled it, but the circles didn't show up, Ed Nash's book, Direct Marketing Book, 2nd edition. Okay? And it shows what it takes to get a 90% confidence level. Okay? All true. All correct. Wonderful stuff. Go get yourself a direct marketing book if you want to know about statistical significance. Except it isn't quite so simple. So, I have books. I have a lot of books. I'll go back to this window. I don't know what order to put these in. I've talked about Freeman Godson Jr.'s book. This is the book that says any consultant who guesses a response rate, you should fire. And this book challenged me to pioneer spreadsheets. As far as I know, I was the only one to give demonstrations on how you could do variable sensitivity testing in marketing with spreadsheets. Okay, back in 1982. Okay, Vic Hunter was this is Tracy Emmerich. Yeah, this is Tracy Emmerich. Tracy and I lectured at a number of places. We were hired by Catalog Age magazine to build a catalog simulation. Did it all over the country. Vic Hunter was my mentor. Nice thick book, business to business. Vic said 50 orders. In B2B, I think that was pretty solid. You try to get a 1% response, and so you're trying to mail about 5,000 name sample sets. Absolutely learned darn near everything from Vic. That's exactly why I know that Chuck's wrong. Because I used to have these little things going with Vic where I would try to prove that something he taught me was not quite on par. And he didn't have a statistical PhD either. He had a master's MBA from Harvard and a undergrad in physics from Purdue, which is absolutely cool. You know, he was a smart guy. He is a smart guy. Okay, here's Dick Shaver's book. Excellent book. Excellent book about the history of direct marketing and about, you know, I'm sure there's charts in there. And also Bob Stone. This book actually has a letter from Bob. I'm cited in the book on the database chapter and also the analytics chapter. Okay, so, and I have my own book. You can read in there. But one time when I was first starting out, I went to Ed Burnett's masterclass. Ed and I became great friends over the years. Bob Stone and I became great friends. I used to stop at his house for coffee. So, you got your chart, I got mine. Let me explain it again. When I was at Ed Burnett's class, there was about 150 people in Chicago, and we flipped coins. And, you know, we just all pulled out a coin. In those days, you carried change. And some of you don't know what a coin is. It's not a Bitcoin. It's like a physical coin. And we flipped the coin, and he stopped at 5, and he said, how many have all heads? Well, as it happened, somewhat randomly, I had all 5 heads. I was the only one in the room who did. Now, as a boy, Jim Bowie was on TV in the 60s. It was a movie about, you know, this rough guy in Kentucky, and he had a big knife. He had a knife and a powerful hand. His blade was tempered, and so was he. Indestructible steel was he, Jim Bowie. Anyway, you learn things you'll never want to know on this show. But that shaped me, and so I learned to throw knives, unknown to my parents, and I ended up almost slitting my best friend's back open, but only cut a line in his shirt about this long. And as he went past me, they took away my knives briefly. But I learned to throw knives, and I also then applied that in college to being able to flip coins, and so I could get 80%, let's say, heads or tails, whichever I felt like at the moment. But whatever it was showing, I could get it to come back, you know, up, down, boom, like that, and do it over and over. So anyway, my data was not part of an even distribution. Do you understand that? Okay. Ed Nash's confidence levels are based on testing potatoes when you're making potato chips. They're the entire category of statistical analysis was about brewing beer and making potato chips, and it started in food manufacturing. And basically the idea is, how many potatoes do we have to test in order to be sure there are no rotten potatoes in the truckload we just got from the farmer, or not that many rotten potatoes? Okay, how many do we have to test to find an unacceptable level of rotten potatoes? So what they do is they take a sample set of potatoes, and they punch a hole in them. And as lengthwise, and as they're cut into potato chips, they'll have holes in them, like that, big holes. And then they'll throw those in the batch with the existing pre-tested potatoes. As they go through the line, they inspect, after frying, they inspect the potatoes, and they know how many, if they're all good, 100% good. And they have a certain number. Okay, let's say they have, I don't know how many potato chips they have, okay? But they have a certain number that they're used to and they're comfortable with. Like, we were used to 50 orders in B2B, and we were comfortable with it. And Chuck is used to 250 orders, and he's comfortable with that. And that's good. At least it's something. At least it's a parameter. Now, that's with potatoes. Potatoes are a homogeneous, more or less homogeneous sample. Okay, there's a normal distribution of excellent potatoes, potatoes that look like Elvis, and rotten potatoes. Okay, but on the index of acceptable for potato chips, there's a distribution. Okay, a normal distribution, because, not every potato is perfect. and some are exceptional. In marketing, that isn't always the case, or in coin flips. And it's possible that you can have a non-equally distributed sample set. Okay? So I called my friend, unlike all these guys who I'm pretty sure don't have PhDs in statistics, I called my friend Matthew Schall, who I met at Musician's Friend, and he was also at Land's End, and he has a PhD, I believe from UCLA, and we talked for about 45 minutes. And I explained my show, and I explained what, that it matters what you did to get the 250 orders that Chuck said is fine. You're fine with 250 orders. Well, you might be fine, and mostly you're fine. Okay? And mostly you're using prospect lists or something. That's how these charts got started. And you're using those, and you're saying, okay, this list, we tested 10. Usually, okay, you say, well, I'm expecting a 2.5% response, so I need 10,000 names. That's how you do this. Okay, this is how it's done in the real world. And okay, so then one list gets you 200, one list gets you 300, and that's a 90% confidence level, significant difference. So you say the list that had 300 is better than the list that had 200. That's all fair. Chuck's right. However, my experience as a marketer, as a modeler for 25 years, as looking at the distributions of customers in nice big mailing lists, like Cabela's 5 million piece mailing. Out of that 5 million piece mailing, there is about 5,000 that pulled over 5,000 orders. Is that significant? It's not significant the way Chuck has got it laid out. If we happen to unknowingly select the best of the best. Now, I did it with a great deal of analytical power and some skill, and I found these guys kind of accidentally, because I had said publicly, there, in my cavalier way that Chuck pointed out, I had publicly said you always have to mail more than you get responses. It's not true. There's a segment of the Cabela's house file that pulled more than 100% response. However, if you get that, you might want to be careful. Because, especially if you think you got it randomly. Now, I didn't. I thought I got it deliberately, and it came in unbelievably great. So here is a principle that Matthew Schall told me about, the Chebyshev Inequality. This is what a real statistician, PhD guy, he could quote this off the top of his head. And he said, this inequality says that in any kind of probability distribution, almost all the values are near to the mean. What does that mean? That means that when you get 5 heads in a row, 5 out of 5, it's likely something's up. There's something fishy. Okay? In short and simple words, when a distribution is not normal. Why is that significant here? It's significant because customer distributions are not normal. In fact, that's why we use chi-squared curves instead of normal distribution curves. Because customer behavior doesn't start at 0 and work its way. When you plot average order size as an example, it doesn't go from 0 and then up and then down like that. It goes, there's a minimum that you can't do less than the minimum. Okay, and so it starts up here at $35 or something. They all start down there because you can't order something less than that because, we charge you shipping if it's $1, except if you buy it from China. Okay, so it starts like this and goes tapering off to the high side only. It's an unequal distribution. That's the way the world is. It's an 80-20. It's never a normal distribution. And what I was trying to point out to Chuck was that unless you're using this, and nobody's using this in direct mail, okay, and much less e-commerce where they don't even know these basics like Chuck is trying to teach us, okay, we use this. And so here's the formula. I wrote him back and I said, Chuck, I'm working with the formula that's used to build the charts, except this formula is more complicated. I went to a number of websites before I called Matthew, and I said, and it says put in what the number you want to test, that's the universe, and put in the expected response rate, and here's your confidence level. Yeah, okay, that is not this equation, and that assumes a normal distribution. And I can tell you, almost no matter how you select customers, potatoes are one thing, but when you select customers, they're never completely normal. Maybe on height or weight, but almost everything is skewed. And we're happy to do a profile and show you the skews in your customers and do models, and we will show you skews all day long. With Cabela's, we had 150 little cell splits per model. All of them illustrated skews. They're all over the place. So, don't think just about 250 responses. Because if you mail 250 pieces, and I could show you in the Cabela's file today where you could get 250 responses. If that happened to you accidentally, remember Chebyshev. Remember Matthew Shaw. It ain't so simple. If you mail 100,000 and get 250, it's pretty likely that's close to the mean result. But if you mailed 250 and got 250 orders, it's pretty close. It's pretty for sure, 100% almost, that your confidence level is more like, Matthew says, a sixth. Okay, so a sixth of 90 is what, 30%? No, a sixth of 90 is 15%. It's pretty certain that your certainty, if you mail 250, would be, and you can do it with this equation. You could figure it out. But he says normally when there is a significant skew, and there is in customer mailings, your confidence level isn't 90, it's 15. And if you've ever wondered why you mailed something, you did a test of maybe you were stupid and you just mailed 1,000 pieces and you got a great result. And maybe you thought, well, let's start with what we think is the best names, and you used RFM or something. And you got, a 10% or a 15% response. Or maybe you even did it out of a mailing list. Maybe you cherry-picked, something big like LL Bean. And you got a great response. You got a 10% response on something. What happens when you mail it again? What happens when you mail the 100,000 and roll it out? You don't get the same result. Isn't that amazing? Statisticians think about these things. So, write me again, Chuck. We can have you on the show. And sorry I was cavalier about it. But you know what? There's a lot of marketing information out there that just isn't right. And part of my job is to explain why. And if you didn't get it, I can give you Matthew's contact information. Have a great day. I'm John Miglash. Like and share. Your friends will think you're smart.